Welcome to the video tutorial for the Sinumarik 828D CNC controller. This tutorial provides more information about programming in the CNC editor. You'll become familiar with the editor and the Siemens CNC programming language and learn more about cycle support with Program Guide. With the geometry processor, you'll create a contour, program an end face machining, and finally simulate the machining. With the help of a simple sample workpiece with contours, pockets and drilled holes, let's create a sample NC program from the drawing. First, change to the Program Manager to create a new NC program there. Select New, then Program Guide G-code and enter a name. Click OK. The editor opens automatically. The editor supports DIN ISO code, technology cycles, and Siemens high-level language programming with parameters, variables, and structures. The soft keys provide you with the usual editor functions, such as copy, cut, or renumber. You can call and parameterize cycles for the widest range of turning, drilling, and milling machining using the horizontal and vertical soft key bars. It's best to first define the raw part. This is necessary for a complete representation of the simulation. To do this, select the Various, then Raw Part soft keys. In the dialog, you can select predefined raw parts and enter the dimensions. Static and animated help pictures support you during parameterization in the dialogs. Click Accept to save the inputs. Now we've defined the raw part, let's create the tools required for turning. Click Select Tool and navigate with the arrow keys to an empty magazine slot. Click the New Tool soft key. The tool list provides you with a catalogue of the most common tool types. First, select a tool type, and then enter the required parameters, like length and cutting edge data. Click In Program to add the tool to the program. Once the tool has been added, the surface can be faced. You can program this very quickly using G commands. Before you can turn the external contour, it must be programmed. To do this, create a new subprogram and program the contour with the geometry processor. Open the contour editor with Turn Contour and New Contour. You can now use the vertical soft key bar to create various geometry elements, such as straight lines and arcs. In this example, you see that first a straight line in X and then a straight line in Z are created. The complete contour then consists of individual geometry elements. You can now call up the subprogram you've created with the contour descriptions in the main program. To do this, select Turn Contour, then Contour, and then Call Contour. Enter the name of the previously created subprogram. Click Accept to close, and then select the cutting cycles. The Sinumarik Program Guide provides powerful turning cycles for cutting the contour. As an example, let's parameterize a cutting cycle for rough cutting the contour. Under PRG, enter an arbitrary name for the newly created program. This is necessary in case residual material is left over. For the undercutting option, you must select Yes, so that machining perpendicular to the axis can also be performed, for example, as the concave radius. Click Accept to add the cycle to the program. A newly created cycle is shown coloured in the DIN program and begins with cycle. You can reopen and machine a cycle at any time. For facing, you should also use the cutting cycle. Add a finishing tool to the program from the tool list. Enter the technology values and select the cutting cycle. In the cycle, you only need to enter a new program name and select finishing as the machining option. No additional parameters are required. Click Accept to confirm. In the NC program, the cutting cycles are used for each of the contours previously called in the subprogram. After turning the contour, we want to turn a thread at the gudgeon. To do this, select a thread cutting tool and simply program the thread using the thread turning cycle. The specification of the outside diameter, the length, and the pitch defines the thread. The cycle also permits the input of other parameters, such as a conical thread, that you don't require here. As a next step, let's mill a pocket on the end face of the bolt. The 0 position of the spindle is specified first. A milling tool is inserted, and the spindle of the driven tool specified as the master spindle with set MS2. The transmit function transforms the axes on the face edge. That is, you program as usual for milling the X and Y axes, and the controller performs the conversion. Let's mill the edge face with a milling cycle for rectangular pockets. First, define the machining level with G17. Then, enter the position and the dimensions of the pocket and click Accept to confirm. The cycle is displayed in the editor. With Transformation of, you can deactivate the transformation for the end face machining and reset the spindle 1 as the master spindle. Now let's drill 4 holes on the end face. Add a drilling tool and select the required transformation functions like before. Use the drill, then drill ream soft keys to open the drilling cycle. In the cycle, select the G17 machining level and the position patterns. By doing this, you specify that the drilling cycle is used on a position pattern with several drilled holes. This is displayed automatically by bracketing the commands with mcall in the program. Click Accept to transfer the inputs. Create the position pattern directly after the drilling cycle, with drill and then position. The position pattern is a complete circle with 4 drilled holes and a radius of 16. Enter this in the dialog and click Accept to confirm. In the program, you'll now see the 2 lines with the cycles bracketed with mcall. This means the drilling technique will be used for each individual drilled hole in the position pattern. As you did for the pocket milling, complete the end face machining with transformation of. Enter M30 for the program end. Finally, the program is simulated. The 3D simulation displays the machining simultaneously with the program execution, including the associated workpiece and tool. This allows you to quickly find any collisions or program errors. The simulation provides additional views, such as 2D and zoom or cross-sections. After an error-free simulation, the program can be run on the machine. In conclusion, we'll briefly summarize the advantages of graphical programming. Unbeatable command scope for flexible and time-optimized parts programs. Program guide graphical cycle support as an extension to the highly flexible Siemens CNC programming language. Faster programming thanks to the powerful CNC editor. And simple contour input with the geometry processor painting by numbers. Thank you for your interest in this video tutorial.